Hi everybody, welcome back to our next derivatives video. So the first thing we're going to do in this derivatives video is we're going to establish a couple of trigonometric derivatives that will be used throughout most of this course. And after we've taken a couple minutes to do that, we'll talk about a couple of the most basic rules that once again you'll be using throughout most of this course and into Calculus BC as well. So we want to get a good grasp of what those rules are and how they work. So before we do that, let's set up some examples of trig derivatives. Now, I'm assuming you have learned these in your class, so I will do a really fast overview of them so you kind of get the chance to memorize these in this video. So I'm not going to write the legitimate or the formal way of a derivative. For example, you might have a function f of x, and the derivative can be denoted as f prime of x, or it can be denoted as d over dx. I'm not going to take the time to do that for each derivative. I'll just write it out, what the function is and what its derivative is. So sine of x, if you were to take the derivative of sine of x, you get cosine of x. If you were to take the derivative of cosine of x, you get negative sine of x. So this, just keep the signs and everything in mind as well. So let's move on to some of the more complex derivatives. So let's start off with tangent. Tangent of x gets you secant squared of x, or secant of x squared. So just a thought bubble here. Secant squared of x and this secant of x squared are basically the same thing. So it's just something you can keep in mind when we're going to do practice with some of the more basic rules above. Now, what else do we have? Let's see, we have cotangent. So cotangent of x equals negative cosecant squared of x, or once again, negative cosecant of x squared. Let's see, we'll have secant of x. Secant of x gets you, I believe it's secant x tangent x. So that's secant x tangent x. And then we have cosecant of x. So these are your 6 really basic trig derivatives, which will get you cosecant, negative cosecant of x, cotangent of x. So let's just keep these 6 derivatives in mind as we go practice some of these rules. So the first 2 rules we're going to learn are the product and the quotient rule. So what is the product rule? Okay, so let's say we have a function a of x, which is equal to a composite function of f of x times g of x. Now, what is the derivative of a of x? Well, you might think just to multiply the 2 derivatives together, but that's not the case because of the product rule. The derivative of our function a of x is going to be f prime of x times g of x plus f of x times g prime of x. Now I'll go through one pretty quick example. So let's say we have our function a of x is equal to 5x plus 3 times 2x plus 4. Now let's say you don't want to factor it out and take the derivative. You can use the product rule. So this will come in handy with trig derivatives too, and mainly trig derivatives because you can't exactly take the derivative after factoring them out in some cases. So let's go ahead and do the product rule in this case. So we're going to treat this as our f of x, and we're going to treat this as our g of x. So what is our derivative? Well, looking at our formula right here, you want to take the derivative of our f function, which in this case is 5, and multiply it by our g function, which is 2x plus 4. Then you're going to add in your plus, and now you're going to take the derivative of g of x, which is 2, and multiply it by our f of x function, which is 5x plus 3. So there will be some cases where the derivative might be negative. You can change the sign later on, but just go ahead and write the plus when you're doing it so you don't confuse the signs at that time. Now we can go ahead and simplify this, and we'll get 10x plus 20 plus 10x plus 6 to get our overall derivative to be 20x plus 26. Now, you'll notice that if you were to FOIL this out, you'd get the same answer, and you can kind of really quickly check this out. So what is the FOIL version of this? Well, let's just 10x squared plus 20x plus 6x, or plus 26x plus 12. Using the power rule, we end up with the same answer. So this is what the product rule is. Now you're going to use the product rule when you're multiplying two functions, as we did in this case. Once again, you can get a lot more complex with trig derivatives. And we'll probably go through quick couple examples of those complexities if we have the time. Otherwise, we can cover them in the next video. So let's talk about the quotient rule. So let's say you have a function a of x, which is equal to f of x divided by g of x. What is a prime of x? Well, for the same reason that you can't just multiply the derivatives of the two functions together, you can't just divide them, which is why we have the quotient rule. So it's a pretty simple way to remember this rule. We'll call this the high function because it's on top, and we'll call this the low function because it's on bottom. So kind of a quick way to remember it is you're going to do low d high minus high d low over low squared, and the d is just derivative. So you're going to do low function, which is g of x, times the derivative of the high function, which is f prime of x, so low d high minus high, or the high function, which is f of x d low, or times the derivative of the bottom function, which is g prime of x, all of this over low squared. So you're going to get g of x squared. Now this rule is not as commonly used as the product rule, especially because it requires a lot more math, and there's a lot of cases. Let's just go down here real quick. So there's a lot of cases where you might have a function like 5 over x, and you can convert this to 5 times x to the negative 1 and use the power rule, which is a lot easier than the quotient rule. So let's go ahead and come up with a quick example. So this is going to be your derivative function. So let's say we have our a of x to be 2x plus 4 divided by 5. Well, what's our a prime of x? Let's go ahead and show you how this works. So we're going to treat this as our low function, right? And we're going to treat this as our high function. So basically this is g of x, and this right here is f of x. So following the rules that we have, we're going to get our bottom function, which is just 5, times the derivative of the top, which is just 2, minus our top function, which is 2x plus 4, times the derivative of the bottom, which is 0, all divided by the bottom squared, which is 25. Now this cancels out because that's just 0, and we'll get our function, or our derivative, just to be a constant, which is 10 over 25, or you can divide both sides by 5 to get 2/5. Now you can do the same thing here. You can write 2x plus 4 over 5 as 2x over 5, and actually let's go ahead and write this as 2/5 x plus 4/5. And if you were to take the derivative of this using the power rule, once again you end up with the same answer, which is just 2/5. So you can see that both of these rules work. Now hopefully you've gotten a pretty solid example and a grasp of what the product rule is. And going a lot deeper into calc, you'll see a lot of trigonometric functions where you have to use these rules. So for example, you might be given a function where f of x is equal to sine x cosine x. Well, what is f prime of x? Okay, well, obviously we can't just use the power rule here because there's no exponents and we have trig functions. So we're going to have to use the product rule. And using the product rule, we get our derivative to be sine x times, well, cosine is negative sine of x, plus sine x gets you cosine x, or the derivative, times, cosine x. And simplifying this, we get cosine squared of x minus sine squared of x. So this is just a really quick example. But in the next video, we're going to talk about a slightly more complex rule called the chain rule. And here's why. Let's say you're given a function where f of x is equal to, sine of 2x. What is the derivative of this function? You're free to go ahead and try this out. but I'm going to go ahead and give you the answer. The derivative of this function is going to be 2 cosine of 2x. Now, I'll leave it up to you as to why this may be the right answer, but you'll find out in the next video. We're going to discuss the chain rule. And the chain rule will come in handy a lot when you're doing practice AP problems.